Now, moving on from fractals, we're going to be talking about recursive sorting. The first algorithm we're going to be talking about is selection sort. Now, recursive sorting is actually extremely beautiful because it's a very logical way of thinking about sorting a list. Now, remember when we talked about selection sort, we said, let's look at an example list. We said, okay, if I want a selection sort, let's say the list for let's say I want to selection sort this list. Now, what I want to do is essentially get the max, or let's say I want to get the minimum, so I'm going to get the min. So actually, let's change this to a 6. So the min of this list is a 3. So I pull out that 3, and I essentially want to selection sort the rest, right? Because if I pulled out the minimum and I sort the rest, then I just combine the minimum with the rest sorted, and I know that I have the sorted list. So luckily, our recursive function that we're writing is supposed to be sorting the list. So we can assume that it's going to sort whatever we give it, and then just combine what we don't give it with the sorted list to essentially get the right answer. Because remember, recursion is all about solving a smaller problem. If our goal is to sort this list, then let's just sort a smaller list and then add in the last element into the correct place. So for selection sort, it's really easy. We're going to say def selection sort of L. Now, let's not worry about the base case. However, in the recursive case, now what we're going to do is basically get the index of the minimum element, right? Because in selection sort, what we're doing is essentially finding the minimum, pushing it to the front. So here we're going to say the index of the minimum is equal to L.index of min of L. So this will tell me where the index of the minimum element is. Then what I'm going to say is, okay, I know I want to do selection sort on the rest of the list, so I'm going to get everything up till I, and then everything after I, so I plus 1 onwards. And this will basically be the entire list except for the minimum. And I sort this. If I've sorted this, then I know that the place where the first element goes, or the place where the minimum element goes, is in the beginning. So I just do L of I goes in the beginning, and I add this in. So this will be our answer. Essentially, I just sort everything but the minimum, and then I put the minimum in the beginning. And this should be essentially the sorted list. Now our base case is really easy. What's the most basic sorted list that we can have? So as we learned in merge sort when we went over it, we know that lists of size 1 are already sorted. So we're going to say if the length of L is less than 2, if it's a list of size 1 or less, then we know it's sorted, so return L. So now we can sort lists really easily. If I do selection sort of the list, let's say random numbers, and I sort this, look at that. 1, 3, 4, 6, 8, so on and so forth. So thinking about how to sort something recursively, we were able to very easily sort a list using selection sort.